Good morning. Well, let me actually put my camera on here so you can see me. Okay, so good morning. It's a beautiful, well, hope it's a beautiful Saturday. It looks like it's going to rain. So, hey, maybe that's better. It rains today and tomorrow, so you can stay home and study for all your exams. I know it's not the most fun thing to do, but I thought it'd be a good idea for me to go through one of the types of problems that a lot of you are struggling with, given how you did on that SPSS assignment, just in case there's one like this on the exam. So let's go over this. So we have two groups, males and females, being compared on self-esteem. As you can see in the upper left-hand corner here, this is a t-test question. We have two independent samples, different sample sizes. We have their means and their standard deviations. And we want to know if they differ on self-esteem. So you see all this table down here, and it's yikes, what do I do? And based on my discussions with many of you, I think some of you are still like, yikes, what am I going to do? So remember, let's do this in a step-by-step process. Step number one, we focus on Levene's test for equality of variance. So I hear Piper in the background, he agrees. So my F value here, and this is an F test, 0.004, its p-value is 0.95. So I'll ask you, is this test statistically significant or not significant? And what's the null hypothesis? So I'll let you think about it, and you should have the answer by now. And if not, I'm going to help you. So the null hypothesis here is that the two variances are equal. It even says that equality of variance, test for equality of variance. So it's your null hypothesis. If we reject the null hypothesis, we'd reject the assumption of equality of variance. Okay, so in this case, our p-value is pretty high. It's almost 1. Remember, probabilities range from 0 to 1. So this is clearly a high probability of finding a value this large or larger. And if our alpha is 0.05 or 0.01, we'd want to reject the null hypothesis if the p-value is less than or equal to alpha. And this p-value is way greater than alpha. So we're not going to reject the null hypothesis. We'll then assume that the null hypothesis is true, that we have equality of variances. So that's step number one. That's done. You can almost like, in fact, you should X this out once it's done, so you don't go back to that by accident. So now we have the two rows, equal variance is assumed or equal variance is not assumed. And we're going to assume equal variance because that's what we just determined. So you stay with this row. And in the assignment, a lot of people went to the wrong row. They went to the second row rather than the first row. That's not right. Here, I mean, the values are not that different here, but their degrees of freedom are quite a bit different. So the next step is to determine if we have a significant effect, and we look at our t-value for this. So our t-value is negative 1.389 because we're staying with the first row. Its degrees of freedom is 387. We're staying with the first row. Depending if we have a 1 or a 2-tailed test, we have two separate p-values here. You'll notice that the two-sided is higher than the one-sided. Low p-values are better than higher p-values. So as I've mentioned many times, two-tailed test is worse than a one-tailed test, or the one-tailed test is better than a two-tailed test. Why? Because the one-tail is lower than the two-tail. In fact, it's the one-tail is half of the two-tail. Two-tail is double the one-tail. So I'll guarantee you one thing on the test, you're not getting both of these. You're either getting the one or the two-tail, and you got to be able to figure out the other one, because I will ask you that. So remember, if you have a two-tail, cut in half the p-value to get the one-tail. One-tail is always better, so it's always lower. If you have a one-tail, double it to get the two-tail, okay? Two-tail is bigger, it's worse. So then what is our conclusion here? Well, if we're using the two-tail test and our alpha is 0.05, we would fail to reject the null hypothesis. In our case, the null hypothesis is that males and females have equal self-esteem. So we fail to reject that, so we cannot conclude that their self-esteems differ. If we had a one-tail test, we still fail to reject it because even though this is a better p-value, it's still 0.08, which is greater than 0.05. Yep. And so we still fail to reject it. Anyway, that's just, I just want to do a real quick video to help you out here. Have a wonderful rest of the weekend. Enjoy yourselves.